Hello, and welcome to Boring History for Sleep. Tonight, we will embark upon a journey into the surprisingly intricate world of residential cabinet shelf pinhole drilling patterns and their associated pin designs, specifically within American homes from the year 1920 to the year 1980. Imagine a quiet evening, the gentle hum of a refrigerator, perhaps the distant murmur of traffic. You reach for a rarely used cookbook on a kitchen shelf, and as you do, a barely perceptible shift occurs. A shelf slightly adjusts, held in place by components so discrete, so universally accepted, that their very existence is often completely overlooked. These are the small, unobtrusive pins that allow for the remarkable flexibility within our residential cabinetry, securing everything from delicate teacups to weighty stacks of dinner plates. But how did these seemingly mundane objects, and the precise patterns of holes that house them, evolve from bespoke carpentry to the ubiquitous standards we encounter in nearly every American home today? To truly understand their quiet yet profound significance, we need to examine their origins and the subtle, often overlooked march towards standardization that unfolded between 1920 and 1980. Our historical journey into the evolution of standardized residential cabinet shelf pinhole drilling patterns and associated pin designs in American homes between the years 1920 and 1980 begins, appropriately enough, by considering the landscape that existed prior to this specific period. Before 1920, the concept of a standardized shelf pinhole pattern in residential cabinetry was, for the most part, entirely absent. Cabinetry, whether built-in or freestanding, was predominantly crafted by individual carpenters or small workshops. This often meant that each cabinet was a custom creation, tailored to the specific dimensions and aesthetic preferences of the homeowner, or the particular style of the house. In this earlier era, adjustable shelving was certainly a desirable feature, but the methods of achieving it varied considerably and lacked any form of uniform design. One common approach was the use of wooden cleats or ledger strips. These were narrow strips of wood, often an inch or so in width, and perhaps a quarter to a half-inch thick, that were securely fastened to the interior walls of the cabinet. Shelves would then simply rest upon these cleats. If adjustability was desired, multiple rows of cleats could be installed at different heights, and the homeowner would then manually move the shelf from one set of cleats to another. This system, while functional, was often cumbersome. Moving a shelf required the removal of the shelf itself, then the selection of a new cleat height, and finally, the careful repositioning of the shelf. The cleats also consumed a small but noticeable amount of interior cabinet space, and their visible presence could sometimes be considered aesthetically less refined than other methods. Another technique involved dados, or rabbets. These were grooves precisely cut into the interior sides of the cabinet panels. If adjustability was not a primary concern, a single set of dados could be cut at a fixed height to permanently house a shelf. For limited adjustability, multiple dados could be spaced vertically, allowing shelves to be slotted into different positions. However, cutting numerous dados could weaken the cabinet sides, particularly in thinner wood panels, and was a labor-intensive process requiring precision joinery skills. Furthermore, shelves in dados were generally more difficult to remove and reposition than those on simple cleats, making frequent adjustment impractical. The more direct precursor to the modern shelf pin system involved what were often referred to as peg and hole systems. In these early iterations, holes were drilled directly into the cabinet side panels. These holes were typically hand-drilled, often with a brace and bit, resulting in considerable variations in diameter, depth, and vertical alignment. The pegs themselves were usually simple wooden dowels, cut to a suitable length, perhaps an inch or so. These wooden dowels would be inserted into a set of holes, and the shelf would then rest directly on top of the dowels. The primary challenges with this method included the inherent inconsistency of hand-drilled holes, which made it difficult to ensure shelves were perfectly level, and the tendency of wooden dowels to wear, become loose, or even break over time, especially under heavy loads. The material of the cabinet itself, primarily solid wood, also played a significant role, with different wood species offering varying levels of structural integrity around the drilled holes. Hardwoods generally held pegs more securely than softer woods, but drilling in hardwoods was more labor-intensive. The absence of standardization in this pre-1920 period meant that if a homeowner wished to add an extra shelf to an existing cabinet or replace a damaged shelf, it was almost always a custom job. Matching the existing hole sizes, spacing, and the particular style of peg or cleat was a matter of individual craftsmanship rather than simply purchasing a readily available, compatible component. This bespoke approach, while showcasing artisanal skill, was inherently inefficient and costly in an era that was gradually moving towards more accessible and mass-produced goods. As the United States moved into the 1920s, a confluence of societal and industrial changes began to subtly push toward greater uniformity in various aspects of home construction and furnishing. The end of World War I brought with it an economic expansion and a growing demand for new housing. The burgeoning middle class desired homes that were not only affordable, but also equipped with modern conveniences. The kitchen, in particular, was undergoing a transformation from a purely utilitarian workspace to a more integrated and often aesthetically pleasing part of the home. Built-in cabinetry, which offered more efficient storage and a cleaner aesthetic compared to freestanding cupboards, became increasingly popular. This rising demand for built-in cabinetry created an impetus for cabinet manufacturers to explore more efficient production methods. The era of purely custom one-off cabinets was gradually giving way to batch production. Manufacturers began to produce cabinets in standardized sizes or modules that could be combined to fit various kitchen layouts. This shift naturally extended to the internal components of these cabinets, including shelving systems. The inefficiency of drilling each shelf hole individually by hand, or precisely cutting each dado for every cabinet, became increasingly apparent as production volumes grew. Initial steps towards standardization in the 1920s were primarily internal to specific cabinet manufacturing companies. A company might develop its own internal system for adjustable shelving, using rudimentary jigs, to ensure that holes were drilled with a greater degree of consistency than could be achieved by freehand methods. These early jigs were often simple wooden templates, clamped to the cabinet side panels, guiding a handheld drill. While an improvement, these methods still had limitations in terms of precision and speed. During this decade, the material for shelf pins also began a subtle but significant transition. While wooden dowels remained common, the introduction of simple metal pins started to gain traction. These were typically straight metal dowels, often made of steel, sometimes with a zinc plating to resist corrosion. Their diameter was usually around 1/4 inch, a measurement that was easily achieved with commonly available drill bits and aligned well with American fractional inch measurement systems. The uniformity of metal pins, compared to varying wooden dowels, offered a more consistent fit and better load-bearing capabilities. However, the exact design of these pins was still far from uniform across the industry. Some might have a slight flange at the top to prevent them from sinking too far into the hole, while others were simply straight lengths of rod. The spacing of these early standardized holes also began to coalesce around practical increments. 2-inch on-center spacing, meaning the center of one hole was 2 inches from the center of the next, became a somewhat common internal standard for many manufacturers. This provided a reasonable degree of adjustability for shelves without requiring an excessive number of holes, which could potentially weaken the cabinet side panels. Other patterns, such as 1-inch spacing, were also explored, particularly in cabinets designed for more specialized storage needs, where finer adjustments might be desired. The distance of these holes from the front and back edges of the cabinet varied, but manufacturers generally aimed for a setback that provided adequate support for the shelf, while ensuring the pins were not too close to the edge, where they might compromise the structural integrity of the panel. The 1930s saw a continuation of these trends, albeit with the economic shadow of the Great Depression. Despite the slowdown in housing starts, the efficiency gains achieved through batch production and nascent standardization remained valuable. Manufacturers that survived the economic downturn often relied on these more streamlined processes to maintain profitability, The concept of interchangeable parts, long a staple of industrial manufacturing, was slowly but surely making its way into the realm of residential cabinetry components. The idea was that a pin from one cabinet in a particular manufacturer's line should ideally fit into another, simplifying both production and eventual repair or modification by the homeowner. During this period, the influence of new materials on cabinet construction also began to be felt. While solid wood remained the primary material, the use of early forms of plywood and fiberboards started to emerge, particularly for less visible components, or as core materials for veneered panels. These engineered wood products presented new considerations for drilling. Plywood, with its layered construction, generally held screws and pins well, but required sharp drill bits to prevent splintering. Fiberboards, being more homogeneous, could sometimes be prone to crumbling around drilled holes if the material density was not optimal or if the drill bit was dull. This subtly influenced the preferred hole diameters and pin designs, as a snug fit was crucial to prevent pins from wobbling or dislodging. The transition from purely custom to semi-custom and eventually to more standardized cabinet production was a gradual process, driven by economic pressures, technological advancements in manufacturing, and changing consumer expectations. Homeowners were increasingly looking for practical, durable, and easily maintainable products for their homes. While the standardization of shelf pinholes and pins in the 1920s and 1930s was still largely proprietary to individual manufacturers, the foundational ideas of consistent hole diameters, predictable spacing, and improved pin designs were firmly taking root. These early, quiet evolutions laid the groundwork for the more widespread and robust standardization efforts that would characterize the post-World War II era, fundamentally shaping the way we interact with our cabinet storage today. The subtle shifts in manufacturing techniques, the slow embrace of metal pins over wooden dowels, and the nascent implementation of drilling jigs all contributed to this quiet, yet impactful, transformation of the American kitchen and its often overlooked adjustable shelving. As we move into the 1940s, the world was consumed by global conflict. World War II significantly impacted domestic manufacturing, diverting resources and labor towards the war effort. Innovation in non-essential areas, like residential cabinet hardware, was largely paused. However, the end of the war brought a profound shift in American society and industry. The returning servicemen, eager to start families and establish roots, fueled an unprecedented housing boom. This post-war era, extending into the 1950s, saw the rapid expansion of suburbs and the proliferation of tract housing developments. This intense demand for new homes, built quickly and efficiently, became a powerful catalyst for accelerated standardization across all aspects of home construction, including cabinetry. The sheer volume of new homes required mass production on a scale previously unimaginable for residential construction. Custom carpentry, while still existing, was economically unsustainable for the vast majority of these new developments. Manufacturers had to find ways to produce high-quality, functional homes and components at an unprecedented pace and cost-effectiveness. This environment was perfect for the further development and consolidation of modular cabinetry. Kitchen and bathroom cabinets were no longer just built on-site by a carpenter. They were increasingly manufactured in dedicated factories, often in a range of standardized sizes and configurations, and then shipped to construction sites for installation. This shift to factory production was the primary driver for the advancement of shelf pinhole drilling patterns. Manual drilling, even with basic jigs, was too slow and inconsistent for high-volume manufacturing. This led to the widespread adoption of industrial boring machines. These machines, often equipped with multiple spindles, could drill numerous holes simultaneously and with a high degree of precision. A common setup might involve a linear array of drill bits, spaced according to the desired pattern, allowing an entire cabinet side panel to be processed in a single operation. This dramatically increased production speed, reduced labor costs, and critically, ensured a consistent and repeatable hole pattern across thousands of cabinet units. The multi-spindle boring machine became a cornerstone of modern cabinet manufacturing, defining the practical limits and possibilities of hole patterns for decades. With the proliferation of these precise boring machines, the concept of a standardized hole diameter solidified around the 1/4 inch measurement. This fractional inch size was deeply embedded in American tooling and measurement systems, making it a natural choice. Drill bits were readily available, and the resulting hole size provided a good balance between structural integrity in the cabinet panel and sufficient strength for the shelf pin. The 1/4 inch diameter became a de facto industry standard for adjustable shelving in American residential cabinetry during this period. Pin design also evolved significantly in the 1940s and 1950s. While straight metal dowels remained in use, the L-shaped shelf pin gained considerable prominence. This design offered several distinct advantages. The horizontal leg of the L provided a broader, more stable surface for the shelf to rest upon, distributing the weight more effectively than a simple dowel. The vertical leg, inserted into the cabinet side, often featured a slightly flared or ribbed profile near its base, creating a friction fit that helped to prevent the pin from easily pulling out or rotating under load. These L-shaped pins were typically made of steel, often zinc-plated for corrosion resistance and a clean, metallic appearance. The zinc plating also provided a smoother surface, making insertion and removal easier while reducing friction-induced wear on the pin and hole. The emergence of these specialized cabinet manufacturing companies, many of which are still prominent today, further propelled the drive for standardized patterns. These companies, producing vast quantities of cabinets, found it economically advantageous to design their products with interchangeable components. This meant that a shelf pin from one base cabinet could be used in a wall cabinet, simplifying inventory management for both the manufacturer and later, for distributors and retailers. This also benefited consumers, as replacement pins were more likely to be readily available. Consumer expectations also began to shift. Homes were becoming more customized in their use, and homeowners desired greater flexibility in organizing their storage spaces. Adjustable shelving, therefore, moved from being a luxury feature to a standard expectation. Families had varying needs for dishes, groceries, appliances, and other household items, and the ability to easily reposition shelves to accommodate these items became a significant selling point for new homes and cabinet upgrades. The standardized 2-inch on-center hole pattern, initially adopted by many manufacturers, proved to be a practical compromise. It offered sufficient adjustability for most common items while minimizing the number of holes, thereby maintaining the structural integrity of the cabinet sides. Other patterns, such as 1-inch on-center, also found their niche, particularly in shallower wall cabinets where finer height tuning might be more critical for smaller items. The precision of these drilling patterns also became a key area of focus. While earlier hand-drilled holes could be somewhat forgiving of minor misalignments, the shift to factory-produced modular units demanded greater accuracy. Shelves needed to be perfectly level across the width and depth of the cabinet to avoid items sliding off or creating an unsightly appearance. This required careful calibration of boring machines, regular maintenance of drill bits to ensure clean, consistently sized holes, and stringent quality control processes. The depth of the holes was also crucial. Too shallow, and the pin might not be securely seated. Too deep, and it could weaken the panel, or even penetrate through to the exterior if the panel was particularly thin. Manufacturers generally aimed for a depth that provided a secure friction fit, typically between 1/2 inch and 3/4 inch for a 3/4 inch thick cabinet side panel. The material of the cabinet panels themselves continued to influence these developments. While solid wood remained a premium choice, the increasing use of plywood, particularly hardwood plywoods for cabinet interiors, became more common. Plywood's cross-grain construction provided excellent stability and resistance to warping, and it generally held shelf pins securely. Particle board also began to gain traction as a more economical core material, especially for less visible cabinet components. Drilling into particle board required specific considerations, as its less dense and more granular structure could be prone to crumbling or expansion if holes were not precisely bored, potentially leading to loose-fitting pins over time. This sometimes led to the development of pins with slightly different shaft designs or the use of plastic sleeves to reinforce the holes in particle board. In summary, the 1940s and 1950s represented a period of significant acceleration in the standardization of shelf pinhole drilling patterns and associated pin designs in American homes. Driven by the post-war housing boom and the imperative for mass production, industrial boring machines became central to achieving precise, repeatable hole patterns, largely centered around the 1/4 inch diameter. The L-shaped metal pin emerged as a dominant design, offering superior support and stability. These developments were not merely technical, they reflected broader societal shifts towards efficiency, affordability, and the increasing expectation of functional flexibility in the American home, setting the stage for further refinements in the decades to come. The quiet efficiency of these standardized systems, though largely unnoticed, underpinned the functionality of millions of new homes across the nation. As we transition into the 1960s and 1970s, the evolution of residential cabinet shelf pinhole drilling patterns and associated pin designs entered a phase of refinement and diversification. The foundations of mass production and standardization had been firmly established in the preceding decades, and now the focus shifted towards optimizing these systems for greater efficiency, cost-effectiveness, durability, and even aesthetics. This era was characterized by continued advancements in manufacturing technology, the widespread adoption of new materials, and a growing awareness of subtle improvements that could enhance both the production process and the end-user experience. One of the most significant developments during this period was the widespread adoption of particle board and, later, medium-density fiberboard, or MDF, as core materials for cabinet construction. While solid wood and plywood remained prevalent, especially in higher-end cabinetry, the economic advantages of particle board and MDF made them incredibly attractive for the mass market. These engineered wood products offered consistency, stability, and a smooth surface for laminates or veneers, often at a lower cost than solid wood or even quality plywood. However, their physical properties presented new challenges for shelf pinhole integrity. Particle board, composed of wood chips and resin, is less dense and more prone to crumbling around drilled holes if not properly handled. MDF, while denser and more uniform, also required precise drilling to maintain hole integrity over time. This material shift directly influenced pin design. Manufacturers began to explore new materials for pins, primarily plastics. Plastic shelf pins offered several advantages. They were significantly more cost-effective to produce through injection molding. They were lighter, and they were non-marring, meaning they were less likely to scratch or damage the shelf itself. They could also be molded in various colors, allowing for better aesthetic integration with different cabinet finishes. The earliest plastic pins were often simple straight dowels or L-shaped designs, mirroring their metal counterparts. However, their design could be further optimized. Some plastic pins featured subtle ribs or flutes along their shaft, designed to create a more secure friction fit within the drilled hole, compensating for the potentially weaker grip of particle board. Other plastic pins were designed with a slightly tapered shaft, facilitating easier insertion while still providing a snug fit. In addition to fully plastic pins, plastic sleeves also emerged. These small, often ribbed or flanged plastic inserts were designed to be pressed or tapped into the drilled holes in particle board or softer woods. A metal shelf pin, usually a 1/4 inch L-shaped design, would then be inserted into the plastic sleeve. This system offered several benefits. The plastic sleeve reinforced the hole, preventing it from enlarging or crumbling over time, and it provided a consistent, tight fit for the metal pin, enhancing durability and stability, particularly for heavier loads. This hybrid approach combined the strength of metal pins with the hole protection offered by plastic. Regarding drilling patterns, the 1/4 inch diameter remained the dominant standard in American homes throughout the 1960s and 1970s. This continuity was beneficial for both manufacturers, who had established tooling, and consumers, who could easily find replacement pins. However, the spacing of these holes continued to evolve and diversify. The 2-inch on-center pattern remained very common. It struck a good balance between providing adequate adjustability and minimizing the number of holes in the cabinet sides, which helped to maintain structural integrity. For many standard kitchen and general storage cabinets, a 2-inch adjustment increment was perfectly sufficient for accommodating items like dinner plates, cereal boxes, or small appliances. However, the 1-inch on-center pattern also gained significant traction, especially in shallower wall cabinets or specialized storage units where finer height adjustments were desired. Consider, for instance, a cabinet designed to hold spice jars or small condiment bottles. A 2-inch adjustment might be too coarse, leaving wasted space above or below items. A 1-inch pattern offered greater flexibility, allowing homeowners to maximize vertical storage efficiency. The trade-off, of course, was that a 1-inch pattern doubled the number of drilled holes in the cabinet sides, which, particularly in thinner particle board panels, could potentially weaken the panel if not properly designed and manufactured. This required careful engineering considerations regarding panel thickness, material density, and the placement of holes relative to the edges. The setback of holes from the cabinet edges, both front and back, also became a more refined consideration. Typically, holes were drilled approximately 3/4 inch to 1 inch from the front and back edges. This ensured that the pins provided adequate support close to the edge of the shelf, preventing tipping, while also preventing the holes from being too close to the very edge of the cabinet, where they might cause the material to chip out during drilling or compromise the structural integrity over time. Consistent setback was also important for aesthetic reasons, creating a uniform appearance inside the cabinet, regardless of shelf height. Beyond the common L-shaped and straight plastic or metal pins, specialty pins began to emerge, reflecting specific needs or advanced manufacturing capabilities. For applications requiring greater stability or load-bearing capacity, some manufacturers introduced threaded shelf pins. These pins would thread into a corresponding metal insert, or sometimes directly into a reinforced hole in the cabinet side, providing a much more secure and rigid connection than a simple friction fit. While less common in standard residential cabinetry due to cost and installation complexity, their existence reflected a growing technical sophistication in cabinet hardware. The influence of European manufacturing began to subtly appear in the late 1970s, particularly with the introduction of the 5mm hole diameter. While the 32mm system, which often dictates a 5mm pinhole, was not yet widespread as a comprehensive cabinet construction standard in American homes during this period, the importation of European-designed hardware and some ready-to-assemble, or RTA, furniture started to familiarize American consumers and manufacturers with this alternative diameter. The 5mm hole, slightly smaller than a 1/4 inch, offered some advantages in material usage and potentially a tighter fit for certain pin designs, especially in the context of precision-engineered particle board or MDF panels. This development, however, would gain much more prominence in the decades immediately following our specific time frame. The manufacturing processes themselves continued to advance. Multi-spindle boring machines became more sophisticated, with increased accuracy and speed. Computer numerical control, or CNC technology, while still in its relative infancy for general cabinet production, began to offer glimpses of the future, allowing for even greater precision and flexibility in drilling complex or varied patterns. Jigs and templates, both for manual and automated drilling, became more robust and durable, often made from hardened steel or precision-machined aluminum to withstand the rigors of high-volume production. The development of specialized drill bits designed to minimize tear-out and chip-out in engineered wood products also contributed to cleaner, more consistent hole quality. The concept of build-it-yourself or DIY culture also started to grow during this period. Hardware stores and home improvement centers began to stock a wider variety of shelf pins and shelf standards, reflecting the increasing consumer demand for flexible storage solutions. While most homeowners were not manufacturing their own cabinets, the availability of these components made it easier for them to add or modify shelving in existing units, often adapting new pins to existing hole patterns or drilling new holes using simple templates. In summary, The 1960s and 1970s were characterized by a meticulous refinement of the shelf pin and hole drilling pattern systems. The widespread use of particle board and MDF necessitated innovations in pin materials, leading to the rise of plastic pins and plastic sleeves for metal pins. Drilling patterns continued to solidify around 1/4-inch diameter holes, with 1-inch and 2-inch on-center spacing being the most prevalent choices, driven by a balance of adjustability needs and structural integrity concerns. The careful consideration of setback from edges, the emergence of specialty pins, and the very early whispers of alternative hole diameters like 5 mm all contributed to a quiet but persistent evolution. These subtle advancements, often unnoticed by the casual observer, collectively improved the functionality, durability, and cost-effectiveness of residential cabinet storage in American homes, serving as a testament to the continuous pursuit of incremental perfection in even the most mundane of household components. As we approach the final segment of our chronological exploration, entering the very early 1980s, we observe a culmination of the trends and innovations that had been steadily developing over the preceding 60 years. This era marked a period of both consolidation of established practices and the nascent influence of new global standards and technologies that would further shape the future of residential cabinet shelf pinhole drilling patterns. The meticulous attention to detail in manufacturing, driven by economic efficiency and consumer expectations, had transformed what was once a bespoke, inconsistent feature into a highly standardized, yet still subtly evolving, aspect of the American home. By the early 1980s, the 1/4-inch hole diameter had firmly cemented its position as the predominant standard for adjustable shelving in American residential cabinetry. This consistency was a significant achievement, simplifying hardware procurement for manufacturers, distributors, and consumers alike. The availability of 1/4-inch drill bits, jigs, and a vast array of shelf pins across the country meant that this dimension was deeply ingrained in the American building and DIY ecosystem. Whether a cabinet was manufactured in a large factory or crafted by a local cabinet maker, the expectation was that 1/4-inch pins would fit. However, the influence of the 5 mm hole diameter, which had begun to make its quiet presence felt in the late 1970s, continued to grow. This growth was largely propelled by two interconnected factors: the increasing popularity of ready-to-assemble or RTA furniture, much of which originated from European manufacturers who favored metric measurements, and the gradual, though not yet complete, awareness of the European 32 mm system for cabinet construction. While the full 32 mm system, which dictates precise spacing and hole patterns for hardware, was not widely adopted for custom American residential cabinetry during this specific timeframe, the smaller 5 mm hole became an alternative for some domestic manufacturers, particularly those producing more contemporary or RTA-style units. The 5 mm hole, often perceived as offering a slightly more refined aesthetic due to its smaller size, also presented technical advantages in certain engineered wood products, as it removed less material from the panel. This created a dual standard. 1/4-inch remained dominant, but 5 mm began to establish a recognizable, albeit secondary foothold. The drilling patterns themselves continued to be refined, with the 1-inch on-center and 2-inch on-center spacing patterns remaining the most common. The choice between these two was often dictated by the specific application. For kitchen pantry cabinets or utility room shelving, where large, bulky items needed to be stored, the 2-inch on-center pattern offered sufficient adjustability with fewer holes, thus maximizing panel strength. In areas like wall cabinets for glassware or bookshelves, where finer adjustments could optimize space utilization, the 1-inch on-center pattern was often preferred. The exact placement of these patterns, the distance from the front and back edges of the cabinet side panels, had also become highly standardized within individual manufacturers' lines. This consistency ensured that shelves, when placed at corresponding heights, were perfectly level and provided maximum support without extending past the cabinet opening. Typical setbacks remained in the range of 3/4 inch to 1 inch from both the front and back edges, balancing aesthetic neatness with structural support. Pin designs in the early 1980s showcased a high degree of material sophistication and functional specialization. Metal L-shaped pins, typically made of zinc-plated steel, remained a workhorse for their strength and durability. These often featured a slightly beveled end for easier insertion and a small, often textured, grip on the L portion to prevent shelves from sliding forward unintentionally. Plastic pins had evolved significantly from their earlier versions. Injection molding technology allowed for complex shapes and improved material properties. Newer plastics offered greater resistance to breakage and discoloration. Many plastic pins incorporated reinforcing ribs, flared shoulders, or multifaceted shafts, designed to create a very secure friction fit in a variety of engineered wood products, including particle board and MDF, which by this point were ubiquitous. Some plastic pins even featured small, flexible wings or barbs that would slightly compress upon insertion and then expand, gripping the inside of the drilled hole more securely. The use of plastic sleeves in conjunction with metal pins also remained a popular and robust solution for ensuring longevity and stability in softer panel materials. Aesthetics played an increasingly important role, even in components as seemingly minor as shelf pins. The desire for a cleaner, more integrated look in cabinetry led to the development of pins that were less visually obtrusive. Some plastic pins were designed to be virtually flush with the inside surface of the cabinet panel, minimizing their projection. Others were color-matched to the interior laminate or veneer of the cabinet, making them blend in more effectively. Manufacturing processes continued their march toward automation and precision. While multi-spindle boring machines were still foundational, the increasing capabilities of computer numerical control, or CNC, machining began to revolutionize cabinet production. CNC routers and boring machines could execute highly precise drilling patterns with unparalleled accuracy and repeatability, adapting quickly to different cabinet designs and hole configurations with minimal downtime for retooling. This allowed manufacturers to offer a wider range of cabinet styles and sizes while maintaining consistent quality in their shelving systems. The precision of CNC also contributed to cleaner holes, minimizing chip out and tear out, which was particularly beneficial for the structural integrity of engineered wood products. The economic drivers behind these developments remained consistent: the continuous pursuit of efficiency, cost reduction, and consumer satisfaction. Standardization streamlined production, reduced waste, and simplified inventory. The subtle improvements in pin design and hole patterns translated directly into more durable, functional, and aesthetically pleasing cabinets, enhancing the overall value proposition for homeowners. The ability for homeowners to easily adjust their shelves to accommodate changing storage needs, from bulky appliances to delicate dinnerware, was now a fundamental expectation rather than a premium feature. This ease of adjustability contributed to the long-term utility and adaptability of residential cabinetry, making homes more responsive to the evolving lifestyles of their occupants. In reflecting on the period from 1920 to 1980, it becomes clear that the evolution of standardized residential cabinet shelf pinhole drilling patterns and associated pin designs was not a sudden revolution, but rather a slow, deliberate, and highly technical progression. It was a story told in fractions of an inch, in millimeters, in the subtle chemistry of plastics and metals, and in the increasing sophistication of industrial machinery. From the individualized craftsmanship of pre-1920 bespoke carpentry, characterized by hand-drilled holes and simple wooden pegs, the journey led through the foundational mass production needs of the post-WWI era, the rapid acceleration of standardization during the post-World War II housing boom, and into the refined diversification of the 1960s and 1970s. The adoption of consistent 1/4-inch hole diameters, the practical implementation of 1-inch and 2-inch on-center spacing, the crucial role of multi-spindle boring machines, and later, nascent CNC technology, the material transition from solid wood to plywood, particle board and MDF, and the innovative development of L-shaped metal pins, then plastic pins, and protective plastic sleeves. All these seemingly minor details converged to create the robust, functional, and largely invisible systems that support the contents of nearly every cabinet in an American home. This 6-decade journey demonstrates how even the most unassuming components of our living spaces are subject to complex historical, economic, and technological forces. The seemingly mundane shelf pinhole, and the pin that resides within it, is a testament to the continuous drive for efficiency, durability, and user convenience in the built environment. Its subtle evolution speaks volumes about the meticulous engineering and thoughtful design that underpins the everyday objects we often take for granted, quietly contributing to the comfort and functionality of our homes. The year 1980 stands not as an endpoint, but as a clear milestone, showcasing a mature standard in American residential cabinet pinhole patterns, poised for the further innovations that the subsequent decades would inevitably bring, yet firmly rooted in the foundational changes of this 60-year period. It is a story of quiet, persistent progress, ensuring that the shelves in our cabinets continue to serve us reliably, holding our possessions securely, year after year, with an understated elegance.